Hello everyone. In this part of the video lecture, I'll be explaining you about the DHCP protocol. DHCP is a very important question that is asked in many university exams. They are asking you to write or explain DHCP protocol. So DHCP is nothing but the dynamic host configuration protocol. So DHCP is used by the network managers to give you temporary or permanent IP addresses inside the network. So as given in the presentation, address assignment is in an organization can be done automatically using the dynamic host configuration protocol. Because of this automatic, the name is given as dynamic host configuration protocol, DHCP. DHCP is in an application layer program using the client server paradigm, which helps actually the TCP IP at the network layer. DHCP is often called a plug and play protocol because automatically we are assigning some address to the host. Sometime it will be there in the network. If it is not there in the network, automatically it can be removed from the network. A network manager can configure DHCP to assign permanent or temporary IP addresses to the host and the routers. It also allows an ISP with 1/4 of the customers use the internet at the same time. Example, 1000 granted addresses to provide service to 4000 households, assuming not more than 1/4 users at the same time. That is, if 1000 addresses have been given for you, same time 4000 people can be using. That is how we are using we are using a one id for the Wi-Fi. Inside the Wi-Fi there are many number of users with user id and passwords. So using one id, many customers can use the internet. DHCP can be used to provide the four pieces of information to the host normally needed: the computer address, the prefix, the address of the router, and the IP address of a name of the server. So DHCP is having a message format. You can see whatever when you are allocating an address to the host, you will be using a format. So here first field is telling totally it is 32 bits of address. So in that it is telling you about each and every field is specifying about its specification. For example, first one is the opcode. It is the operation code, request or reply. It is telling what is the operation is to be done. H type is telling about the hardware type, Ethernet. Then H length is telling about the length of the hardware address. H count is telling about the maximum number of hops the packets can travel. Likewise, you are having your transaction ID, time elapsed, flags, client IP address, your IP address, server IP address, gateway, everything you can go through. So these are the different fields. Last one is your option. Option is a 64 byte field which with the dual purpose described in the text. So next you can see how the option format is used, because last one I told it is option format. The option format will be used. Option is composed of three fields: 1 byte tag field, 1 byte length field, and the variable length value field. So DHCP discover means it is discovering the host. DHCP ACK means it is the acknowledgement. NACK means negative acknowledgement. DHCP release is for the release. DHCP inform is for the information. Decline, request, offer. Likewise, first you are having a tag field that is 53. Then you are having a length field. Then you are having a value. Value is telling about the variable length of the value field. Next we are having the one of the example is given for the DHCP operation, how a client IP server is sending the information to the server, and from server how it is going to the client using the time, everything. Here the format, as I told you, whatever format we had seen previously, in the similar format data is being shown in the operation. So this is about the DHCP operation. Then using the DHCP operations, we are having the finite state mission to explain how the DHCP is actually working. FSM for DHCP client, that is initial state, then you are going to select, then your request, then you are going around renewing, rebinding everything. So you can see what are the operations that is going on in the DHCP in detail. You can write and explain. Then you are going for the network address translation, NAT. NAT is also one of the important questions that is asked in the university exams. NAT stands for network address translation, network address resolution. So NAT enables a user to have a large set of address internally and one address or a small set of address externally. That is, we are getting from the outside world as a one unique address. That unique address will be dividing it into many number of addresses inside the network. So we call them as a local or a private address. When it is going to the outside world, then it is a original logical address. Inside the network, it is a private address. So in the example, you can see there are some space, some private network, private addresses that only can be used for the addresses inside the network. So inside the network, you will be having one address. When the same thing is going outside the network, it will be having a different address, that is a unique address. So this transformation of private to a unique is done by the network address translation router, that is NAT. So you can see in the diagram, you are having in the yellow color, you can see there are three ranges of address, that is from 10.0.0 to 10.255, 255, 255. That is 2 power 24 addresses are kept private. Then one more in the range 172, then one more in the range 192. These three are the ranges that is used for private addresses. So whatever is there in the yellow color is assigned by the network manager inside the network. So when this address is going out of the network, you can see inside the network the address is starting from 172. But whereas when it is going out of the network, it is using the number 200.24.5.5. 8. So this is the task of the network address translator, that is converting your local or the private address into a unique logical address in the internet. That is done by the NAT. Here also in this example, same thing is happening. Inside the network, it is having a local address. When the same thing is going out of the address, it will be converted to a standard address. That is address translation is happening, that is private to logical address. Address translation of a source address of outgoing packet and for destination address in the incoming. You can see that when it is going from private to outside also, it is getting converted. From outside to inside also, it is having a conversion. This is the task of the network address translation. So for translation, usually it will be using the different procedure. One procedure is using one IP address. Second one is a pool of IP address. Third one is both IP address and the port numbers. So these are some of the methods how your address can be converted. Either by using only one IP address, when all private addresses, when it is going out, it can be converted to one IP address. Or you will be using a pool of IP addresses. Depending on your subnets, you will be using a pool of IP addresses, or both you can use your IP address and the port numbers. This is using the address translation table. Here also you can see the address translation table, how it is happening using the port numbers. ISP and NAT, that is internet service provider. When it is going out of the ISP to the internet, then there are network address translators are being used. So this is how the network address translation is taking place. With the diagram, you have to explain this one in detail. So forwarding of IP packets, when IP packet is used as a connectionless protocol, forwarding is based on the destination address of the IP datagram. Similarly, IP is also used for connection oriented, because as we have discussed previously, whenever the data is packet switching is happening, it will be happening in two different ways, that is datagram approach or it is a virtual circuit approach. One is connection oriented, another one is connectionless service. So here also you have to use the NAT. This is the simplified or forwarding module in the class of the addresses. Then we will see how making forwarding is happening in the network. This is how the forwarding, using the table, it is going to forward the data using a connection oriented service, or the every router is knowing what is the next label the data has to be transferred. So likewise the data is getting transferred. This shows the forwarding process in a packet arrives R1 in the figure in the destination with the address 180.70.65. So this is hierarchical routing, that is as we have told, every address in the network is having a hierarchy. From the top to bottom, it will follow all the hierarchies. Then when it is going out of the network, a regional ISP will be given the address translated address. Then forwarding is based on the destination addresses, so which is the route it has to follow. Everything is decided by the network address translation table. Forwarding based on the label can also be done. Then we are using multi protocol label based switching, MPLS. That is when there are many number of users in the network, then we have to go with the multi protocol label switching, MPLS. So these are the different types of addresses and address translation. So this is the end of module 3. So please all of you, even though module 3 is a very lengthy module, you have to concentrate more and prepare well. And there are some numericals in this problem, you can score marks in this problem. And this is a easy module where you will be having a scoring. And some of the protocols here used here are also there in the lab. When we are doing experiments in the lab, we have to have the knowledge of this IP addresses. What is IPv4, what is this connection oriented, what is this connection less, everything we have to have more knowledge in the lab experiments also. So please concentrate on this one, do well. Thank you.